What are transaction patterns and how are they used in the Radicore framework to achieve rapid application development? In this presentation, I'm going to describe transaction patterns and how they can assist in the rapid development of web-based enterprise applications which deal with dozens of business domains, hundreds of database tables, and thousands of user transactions. These applications can be characterized as follows. They have a front-end layer or a user interface with which they communicate with external users. They have a back-end layer, also known as a persistence layer, which provides access to a database. They have a middle layer which performs all data validation and processes the business rules. Splitting the application into multiple tiers or layers follows the principle of cohesion, which is the basis for the single responsibility principle and separation of concerns. This has been extended to form the three-tier architecture and the model view controller design pattern, which can be merged to form the structure shown below. This structure operates using the request-response cycle, which has the following steps. 1. An HTTP request is sent by the client's browser and is received by a controller which translates that request into one or more method calls on one or more models. 2. Each model is responsible for a different database table and contains methods to deal with the business and validation rules for each of the create, read, update, and delete or CRUD operations. 3. The DAO or data access object is called from the model to construct and execute every SQL query. 4. When the model has finished its processing, the view will extract its data and format it for presentation to the client. This is usually HTML but could be CSV or PDF. In the Radicore framework, these components have the following reusable elements. There are 45 pre-written and reusable controllers, one for each transaction pattern. There are 3 pre-written and reusable views, one for HTML output, one for CSV, and another for PDF. There are 4 pre-written and reusable DAOs, one for each supported DBMS, MySQL, PostgreSQL, Oracle, and SQL Server. Each model is generated by the framework, but 100% of the common code is inherited from an abstract class. Each controller can be reused with any model. Each model can be reused with any controller. What do I mean by transaction? A transaction is a unit of work which enables an end user to carry out their business duties. This is also known as a business transaction to differentiate it from a database transaction. Other names are use case or task. An application may have a large number of different tasks to deal with each database table, such as create product, read product, update product, delete product, list product, search product. Create customer, read customer, update customer, delete customer, list customer, search customer. Create order, read order, update order, delete order, list order, search order. Similar tasks may be needed for every table in the database. There may be specialized tasks such as cancel order, approve order, generate pick list, pick from inventory, and assemble shipment. What do I mean by pattern? Any regularly repeated arrangement, something that repeats in a predictable manner. A pattern may be visual, such as a design or layout, or it may be behavioral, some process which is performed several times. Patterns in software may be dealt with in several different ways. They can be implemented by putting the repeating code into a module which can be called multiple times instead of being duplicated multiple times. They can be implemented using templates which contain the repetitive structure into which the unique elements can be inserted. An example would be an XSL style sheet which defines the structure of an HTML document from which multiple copies can be created which have the same structure but different content. Common protocols can be placed into an abstract class so that they can be shared by being inherited into multiple concrete classes. This approach enables the use of the template method pattern, whereby the invariant methods in the abstract class can have their logic extended by allowing each concrete class to specify its own implementation in customizable hook methods. What do I mean by transaction pattern? Unlike design patterns, which are nothing but descriptions of designs without any sort of implementation, you have to write the code yourself, transaction patterns are more like templates of pre-written components which enable you to link a model or database table with a transaction pattern and create a working transaction at the press of a button without writing any code. All the repetitive boilerplate code is handled for you, even the data validation, so all that is left over is to insert the unique business rules into each table class. Why are patterns useful in object-oriented programming? The primary aim of OOP is to use encapsulation, inheritance and polymorphism to increase code reuse and decrease maintenance. The more reusable code you have to perform repetitive tasks, then the less code you have to write. The less code you have to write to get the job done, then the quicker you can get the job done, and that will make you more productive. If the same logic is required in multiple places in your code, and each of those places contains a copy of the same code, then this is considered to be a violation of the try or don't repeat yourself principle. If you have to change that logic, then you would have to make the same change in multiple places, and this is where errors can occur. Before you can put code into a module so that it can be reused instead of being duplicated, you have to identify a repeating pattern in your application. The more repeating patterns you can find, then the more reusable software you can create, and the less code you will have to write to implement those patterns. How do you identify patterns? The best way I have found to identify patterns is to follow the advice given in a paper called Designing Reusable Classes, which was published in 1988 by Ralph E. Johnson and Brian Foote. They describe a technique known as programming by difference, in which you examine several components in order to separate out the similar from the different, the abstract from the concrete, so that you can place the similar in reusable and shareable components and isolate the differences in separate and unique components. For example, if you find several classes with similar protocols, methods or operations, you can move those protocols to an abstract class which can then be inherited by every concrete class. What patterns or similarities can you find in an enterprise application? A large enterprise application may contain a number of small applications, which I call subsystems, each of which deals with a different business domain. Each of these subsystems or domains has the following similarities. It has its own database with its own set of tables. It has its own set of transactions. Each transaction performs one or more CRUD operations on one or more database tables and may process any number of business rules. Note that tables in one subsystem's database can be accessed by other subsystems so that data can be shared instead of being duplicated. For example, product data in the product subsystem can be shared by the order processing, inventory and shipment subsystems. What patterns or similarities can you find in different database tables? Each table, regardless of what data is being stored, has a structure which follows the same set of rules. Each table can contain any number of rows, each of which conforms to that structure. Each table, regardless of what data is being stored, is subject to the same operations, which are create, read, update and delete, or CRUD. What steps are performed in every transaction? Each task performs one or more operations on one or more database tables. Each task has components in the presentation, business and data access layers which work together in harmony. The controller translates a request into one or more method calls on one or more models. The model handles the processing of business rules and, if necessary, communicates with the database via the DAO, which performs one or more CRUD operations. When the models have finished their processing, the controller will activate one of the views. Note that some controllers may not have a view. The view will extract data from the models and transform it into the format requested by the user. What steps have the same processing rules? While the data which is being moved between the different layers may be different, the steps required to perform that movement are exactly the same. The rules for sending and receiving HTML documents are the same. The rules for constructing and executing SQL queries are the same. The rules for moving and validating data between the presentation layer and the data access layer, which is performed by the model in the business layer, are the same. What aspects are unique? The data which is being processed, the business rules which apply to that data. What patterns can you find in user transactions? It is only after writing large numbers of transactions that it is possible to identify the similarities and the differences. My personal experience has enabled me to characterize each transaction under the following headings: structure, behavior, and content. Structure: what the HTML form looks like, how many elements it contains, how they are positioned, and how they are related. Each form has different bits of data appearing in different zones or areas, such as the title, menu buttons, navigation buttons, data area, pagination and scrolling controls, and message area. Some of this data is provided by the framework, while some is provided by the models. Behavior: how many models it accesses, what actions it performs on each model, either automatically or by user selection. As the only operations which can ultimately be performed on a database table are the CRUD operations, each model must support these operations with corresponding methods. Content: what data from each model is displayed in which zone on the screen. Each of these can be provided by the following components. Structure is represented by the view which constructs an HTML document from an XSL style sheet. The framework contains just 12 pre-written and reusable style sheets. This means that I do not have to create a separate style sheet for each different screen. Behavior is represented by the controller, which performs different sets of operations on each of its allocated models. As every model supports the same set of operations, this means that each controller can access any model using the same set of methods. The framework contains just 45 pre-written and reusable controllers. This means that I do not have to create a separate controller or set of controllers for each model. Content is represented by one or more models where the data from each model goes into a separate zone on the screen. Note that as SQL queries may contain joins to other tables, it is possible that the output from a model may contain data from a mixture of tables, and that data will be displayed in that model zone. Each model contains its own set of customizable methods to deal with its unique business rules. How is a transaction defined? As the structure and behavior go hand in hand, each transaction pattern combines a particular view and a particular controller. In order to create a working transaction, the developer simply has to link a particular pattern with a particular model or models and press a button. The transaction will be generated and will be immediately available to be run from an online menu. Each transaction will have its own component script in the file system, which will look like the following. How is the screen layout defined? The screen variable points to a screen structure script which looks like the following. Common transaction patterns. Different tasks are usually known by the forms or screens which they display. Tasks are rarely run in isolation. Instead, they are grouped into families which can form hierarchies. The following diagram shows the 6 tasks with which I started my collection to view and maintain the contents of a single database table. Hierarchies of parent-child tasks. In the above structure, you must be within the parent task before you can activate any child task. Any child task can have children of its own, thus forming a hierarchy of tasks and subtasks. The task at the top of the hierarchy can be activated from a menu button. Child tasks can only be activated from a navigation button within a parent task. Each task has its own set of navigation buttons. Note that I do not have large controllers which are responsible for multiple tasks, as that would violate SRP. Instead, each task has its own controller, which makes them smaller, easier to manage, and easier to convert into reusable components. A controller can only be connected to a single view. Note that some controllers do not have a view. The update, delete, and inquire tasks cannot be activated unless one or more rows have been selected in the parent list screen, as they each need to read records from the database before they can complete their assigned function. The insert and search screens do not require any rows to be selected before they are activated. Screen structures. Every screen contains a number of zones or areas, some of which are filled in by the framework, while others are filled in with application data which is provided by models. There are basically two ways in which application data is arranged on the screen. The list view, in which multiple rows are arranged horizontally across the page, with the column labels on the top and rows of data underneath. The number of rows per page which are displayed is configurable, starting at 10 with options for 25, 50 and 100. If multiple pages of data are available, there will be a pagination area to allow the user to move backwards and forwards between them. The detail view, in which a single row is arranged vertically down the page with column labels on the left and data on the right. If multiple rows have been selected, there will be a scrolling area to allow the user to move backwards and forwards between them. Screen behaviors. List screens perform list tasks which read any number of rows from the database using whatever selection criteria which has been passed to them. Detailed screens deal with one row at a time and may be used in several tasks such as create, read, update, delete and search. Create tasks start by displaying a screen with empty fields, allow the user to enter data into those fields, and when the submit button is pressed, the data is sent to the server so that it can be validated before it is inserted into the database. Read tasks must be given one or more primary keys so that the selected data can be read from the database before being displayed one row at a time. All the fields are read-only, so cannot be changed. Update tasks start the same as read tasks, but allow fields to be changed. When the submit button is pressed, the data is sent to the server so that it can be validated before being updated in the database. Delete tasks start the same as read tasks, but if the submit button is pressed, the server will validate that operation before that row is deleted from the database. Search tasks start by displaying a screen with empty fields. The user can fill in any of those fields, and when the submit button is pressed, that data is returned to the previous list screen as selection criteria so that it can reread the database. Variations in list screens. There are several variations of the list screen which deal with different numbers of models or tables. List 1 accesses a single table. List 2 accesses two tables in a parent-child relationship. List 3 accesses three tables in a parent-child-grandchild relationship. List 4 accesses four tables in a parent-child-grandchild-great-grandchild relationship. Each of these tables will be accessed separately by the controller, and their data will be displayed in separate zones on the screen, one above the other. The bottom zone will show multiple rows in a list view, while the previous zones will display one row at a time in a detail view. Each table in these hierarchies will be accessed in the sequence in which they are defined, which is top to bottom. The controller will start from the current row in the parent zone, extract its primary key, convert it into the foreign key of the child, then use this to retrieve related rows from the child. If the child has a child of its own, this process will be repeated until the last table in the hierarchy has been processed. Notes for list screens. Note that there is no code required in any parent class which controls access to any child tables. Converting primary keys into foreign keys and then reading the child table using that foreign key is handled automatically within each controller. Any child tasks are the same as described for the list screen described previously, with the only exception being that for list 2, 3 and 4 parents, the insert task will be past the primary key of the current parent so that it can be used as the foreign key in the child. With this arrangement, it is not possible to navigate down to a child table without going through a screen which allows you to select its parent. Jumping from one task or screen to another. Each task can be one of two types: a menu, which can contain a list of tasks, a proc or procedure, which is a user transaction. Every screen potentially has two rows of controls which allow the user to jump from the current task to another task. A number of hyperlinks in a menu bar which is located at the top of the screen. Each option can be either another menu, thus producing a hierarchy of menus, or a proc. There is only one set of menu options for the entire application. A number of buttons in an optional navigation bar which is located below the menu bar and the screen title. Each of these options must be a proc. Each task has its own set of navigation buttons, one for each of its child tasks. What happens when a new task is selected? When a menu option is selected, the action taken will vary according to the task type. If it is a menu, then the list of options being displayed in the menu bar will be changed. If it is a proc, then the selected task will be activated without any selection criteria, which will cause all areas below the menu bar to be altered to accommodate the output generated by that task. As well as application data, this may include the contents of the navigation bar. Each task in the navigation bar is a child of the current task because of a parent-child relationship between two tables. When a navigation button is pressed, the primary keys from one or more rows in the current task are extracted and passed to the child task in a selection string when that task is activated. If the current task is displaying data in a list view, then individual rows may need to be selected before the navigation button is pressed. If the current task is displaying data only in a detail view, then the primary key of the current row is automatically selected. Writing less code. The ability to spot repeating patterns allows the developer to move the code which implements those patterns into objects which can be reused instead of being duplicated. This means that the developer can achieve the same results but with less code. However, there are other ways in which the same results can be achieved with less code, thus avoiding the common mistakes which I have seen in other people's code samples. 1. Creating wrapper functions. I noticed in several code samples that when several steps were required to carry out a task, that each step, such as load, validate and store, was called separately, which therefore required the same block of calls to be repeated in different controllers. This is a common mistake that can be avoided by placing that repeating group of function calls into a separate wrapper function, thus replacing multiple function calls with a single call to that wrapper function. This also makes it easier to mend the contents of that wrapper function in the future should a change be made to the number of steps. 2. Avoiding method names which are tightly coupled to particular models. Even though classes for database tables share exactly the same CRUD operations, I have seen it suggested in numerous places that method names such as createProduct, createCustomer and createOrder should be used. This idea destroys all possibility of polymorphism because it ties each controller to a particular model. By using a generic and non-specific insert record method in all table classes, it then means that the controllers can be reused with any model using that mechanism known as dependency injection. 3. Avoiding individual property names when transferring data into and out of model objects, as this requires non-shareable code to specify each of those property names. Non-shareable code automatically produces tight coupling between the two objects which are exchanging data. This destroys polymorphism and the ability to use dependency injection. As data being sent in from the browser or retrieved from the database is presented as an associative array, it would surely make sense to pass this data around in that array instead of having unique and non-shareable code to unpack the array into its component parts so that each component can be transferred individually. Common table methods. By using the above techniques to reduce or eliminate the causes of tight coupling, I have created a set of common table methods which exist in the abstract table class similar to the following. Note that all data is passed around in a single field array argument which is used both as input as well as output. These wrapper functions are defined in an abstract class and can therefore be treated as template methods as described in the template method pattern. The invariant methods in the abstract class can then be interspersed with empty hook methods which can be overridden in any concrete subclass in order to provide customized processing. For more information, please refer to the following. Don't applaud, just throw money.